we first met in Geoshare about 2 years ago in the same room. And for those of you who were here, I gave a presentation then, and this is kind of what's happened in the last 2 years from my work related to that. You hear me now? Is that better? No. Okay. And I showed a map. It's interesting because you just talked about the global cropland or the MODIS data sets and things like that. And I showed the JRC Global Land Cover 2000 data set, which has 12 different types of forest classes and 1 for cropland. And that drives me nuts. We just have this one cropland data set. But we have data sets like SPAM that show us where we think those crops are within that cropland extent. And I started thinking, could we do something a little better, particularly looking at the different centers like IRI or CIMMYT that have a mandate for a specific crop. So can we get better crop-specific information into these kind of models? So what can we do? And this is some of what we've been able to do, particularly for rice in Asia. There's a lot of literature out there on using remote sensing to map some of these crops. These crops have specific signatures that you can try to interpret with the remote sensing data. And in the case of Asia, rice covers almost 50% of that kind of cereal cropland. It's a big chunk of real estate in Asia. So the idea is, if we could improve just the rice information, where and when is rice grown, models like SPAM would be able to not only improve the rice distribution, but it would have a significant contribution to the other crops, how you allocate where those other crops have to be. So this is what we did, just to try it out. There's an algorithm that's been published by Zhao using MODIS data to map irrigated and lowland rice agriculture. It's a fairly simple automated algorithm. I think you can actually do better, but this is a really, really good starting point. And what we did is that we applied it to MODIS data in Asia, which means a lot of MODIS tiles. These tiles are pretty big. There's about 13 years of data already accumulated. And the MODIS product that we're using is available every 46 days. So you can see that's a pretty large amount of information to trawl through to try to see where rice is grown. MODIS data in this case, it's 500-meter resolution, but what we're interested in is matching it to things like SPAM. So this is the area we're talking about, and these are the MODIS tiles, and you can see it's quite a big chunk of land that we had to go ahead and process. Briefly, how the algorithm works. The principle is that irrigated and lowland rice has a very strong water presence in the field at the beginning of the season. So it's a very distinctive signature that you can try to track using these vegetation and water indices over time. And you have this flooding, followed by very rapid growth in the biomass. So we can use certain vegetation indices, and temporarily we can see for a particular pixel, here's this kind of NDVI, the vegetation signature that we see. And down here is a kind of a water index. And the algorithm simply says, if we see that the water index is stronger than any of our vegetation indices, and then that's followed by a rapid increase in vegetation, chances are that's a rice area. Now you can of course see there's some issues already. You might misclassify with wetlands and other land cover that have a temporal dynamic with the water and vegetation, but this is the principle. The algorithm looks a little bit like this, so you're using a lot of other data sets too. You're trying to mask out a priori, get rid of the clouds, take out the snow, make sure we get water removed, take out evergreen vegetation. So you can use this temporal data to take all this stuff out. And then you're left with an area that potentially is rice. You do a few other checks based on slope and elevation and other things, and in the end you come up with a map that shows you where rice is grown. That's the principle. Right. So this is what we did. So first of all, here is what you have in SPAM. This is the SPAM 2000 data set, showing where rice is grown in Asia. Everything in green is where SPAM has a very high density of rice. You know, it's the dominant land cover. Everything in gray is where there is some rice. Not a massive amount, but it's part of the kind of mosaic of the cropland. In general, it's got it right. The pattern looks good, This is where we expect rice to be grown, but it's too diffuse. You've got rice in places where there probably isn't any rice, and the places where there is rice, there should be more. It should be denser. It should be much more intensive. So that's the SPAM data set. Very good, but SPAM, you're working really hard to get census data down to a pixel level. So we're trying to go from the bottom up using this approach. So this is the IRI-based map using the MODIS data. And again, green is where it's dominant, and gray is where there is some rice. It's generally the spatial pattern's the same, but it's much more concentrated. I'll just flick back and forth between the two, and you can see some of the difference that we've been able to introduce by this new map. So that's where we are so far. It's not perfect. We've still got some questions. I think this is probably wetland down here, not rice. I'm really not sure that there really is that much rice in northwest China. It could be cotton or some other crop we're picking up there. I don't know. Trying to find information on what's going on up there is not that easy, but we just highlighted that. And here in Sumatra we've got some issues, and I think this is to do with cloud cover, fragmentation, and all these other things there. It's a really complicated landscape. But anyway, it's a good start. So this is kind of how we can feed into Geoshare and other workflows on the where of a crop. And I think if we could do the same kind of thing in other regions for other major crops, we could really dramatically improve the prior information and hence improve what you're trying to do with crop mapping. So this is where. The next question is when. And I get the sense that we don't focus enough on the cropping calendar information. We always focus on the maps, tell me where it is, but not enough on when it's grown. When is it planted? When is it harvested? And it's really important if you want to run your crop modeling. You need a window. Tell me when this crop is planted. Tell me the maturity. When is it going to be harvested? You want to look at stress impacts. Climate change is important, of course, for agriculture. But particular events that cause stress on the plant may be important at the reproductive stage, the seedling stage, and other stages. And you need to get this right if you want to understand the impact of these different climate shocks on your productivity. And again, it also contributes to the improvement of these global data sets. In multiple cropping systems, where you have 2 or 3 crops a year, if you can get the timing right for one crop, you force the other crop to go into the next appropriate season. So you can try to improve it temporally as well. So what we did, we went across the whole global rice science partnership, and IRI is just one partner in that, to get together the best cropping calendar data we could. This isn't remote sensing based, this is just collecting, as Naveen does, census type data. Tell us what we know about cropping calendars. So we ended up with about 2,000 spatial units, and I think this is about 10 times more than you'll find in some of the other data sets out there that have cropping calendar information. And this is what we see for rice for the main growing season, season number 1. And this is just the planting date, colored by the different months. And what we've done in the data set itself, which I'm not going to show, is not just give you the start date, but we give you a window of dates. Some people plant early, some people plant late, most people plant somewhere in between. So we've tried to give you a range. For each of these spatial units, a range of planting dates and a range of harvesting dates. This is the second growing season. So areas where rice is grown a second time. And this is the very small area where we think there's a third crop of rice. The China one needs a little bit of interpretation. It's not strictly a third cropping season. What they do there, they have an early planting of rice, a late planting of rice, so they'll have a double crop. But some people will have an intermediate length of seasons. So they have 1 season, 2 seasons, but some people will have a third distinctive season. But they're not doing 3 crops, just 3 distinctive cropping seasons. Out of the 162 million hectares, we reckon about 113 is planted in the first season, about 44 in the second season, and about 5 million hectares is where they have triple cropping. So you're getting an indication of the cropping intensity of rice. This allows you to talk a lot about when does rice come onto the market, when do we expect that huge production to hit the market. And you see here that it pretty much all occurs in 3 months of the year. September, October, November is where most of this kind of 700 million tons of rice comes onto the market. You can also start to look at how much rice is actually on the ground in any one month. So it's kind of how much real estate is taken up by this crop. And here I'm going to compare what we've done against the Mirka 2000 data set, which has monthly areas. And again, we see Mirka has got it pretty good. It's a pretty good relationship, but I think it's too diffuse again. I think there's too much rice in the dry season, and I think perhaps the duration of the crop is not quite correct. So what we've done with our data set, we see a much lower rice area in the dry season, increasing into the wet season and reducing again. Again, I think it's an improvement on what's already there, just because we're trying to focus on all the partners that we have in the region and trying to introduce a lot of expert knowledge as well into the maturities of the varieties grown in different places. Why I think it's really important, particularly for rice, looking at the impacts of extreme events in climate. This is just a very simple map showing typhoons, hurricanes, cyclones, where they all hit. You can see particularly Southeast Asia has it pretty bad. And this becomes important when you go back to this rice area, how much is in the ground at any one time. This is it for Asia in dark blue, and the light blue part is the contribution of the other rice growing areas of the world. And this is what happened when you look at tropical storm frequency in Asia over the last 50, 60 years. It's a fairly striking correlation between the exposure to risk from these kind of events and when rice is in the ground. So getting this kind of temporal information is really important, not just for modeling purposes, but it's got real practical implications if we can drill down and provide this information to people on when they really need it. So my key message here is that when is at least as important as where, and sometimes I feel we don't focus on the when enough. Not just the time series over multiple years, but within a year, what's going on in our agricultural systems. And regional nodes like IRI could provide not just data, but give you access to a bigger network. We're not just individuals. I think that was an interesting point in the previous presentation. These nodes are consortiums in themselves. They represent a user group. How do we get these into workflows? How do we fuse these? I don't really have the answers to these questions. I'm just trying to see how we as a node could contribute to this whole data fusion concept. What can we bring in? And how can we demonstrate best practice in data sharing and fusing? Encouraging others to open up their data so that we can do a lot more of this kind of work, not just for rice, not just for Asia, but look across all the other mandated crops and get this into these kind of workflows. And that's it. Thank you very much.